All right, so something valuable for us to have here in our manufacturing facility is a climbing wall. And so as things are coming off our wood line or coming off our plastic department, especially from an R&D perspective, we want to get it onto the climbing wall. We want to get our hands on it, start feeling it and getting that feedback instantly. So being here right in the same space, we can accomplish that. It's also really nice for marketing or even setting and various different things. And so as we build this climbing wall, we just want to bring you along, kind of show you the things that we're thinking about, the process that we're taking, and then materials we're using and how we're doing that. And so as we build that, we're going to dive in and show you what we're doing. One of the first steps as we're thinking about designing our climbing wall is understanding our space. And so Sean and I are going out there and we're looking at the physical limitations of the space. And so we don't have this clean corner that we're working in, as we have the cinder block walls and we have these two structural supports that kind of protrude out from the wall. And we have a sprinkler drop, for our sprinkler system that comes down, some piping that we have to work around. In your situation, you might have some steel beams dropping into the middle of your space. And so step one is kind of understanding, all right, what are the physical limitations of my space? What am I working around? And then after that, then we're going to get our measurements, your basic height and your width. And then we can start taking those to the restrictions and then our measurements. And at the same time, we're also working through, all right, what are the needs of the wall? Is this a bouldering wall? Is this a top rope wall? Do I want vertical sections? Do I want a slab? Do I want an overhung area? And then once you have that all figured out, that's where we can start designing. And so we get the designs in at the same time, have someone start thinking through the aesthetics, and then all three of those, it's like a big mixing pot. We're mixing in all those variables, design angles, the aesthetics, the wall angles, and then we start to bring that to life in the computer. And so then we can create our visual mock-ups, we can play around with that, and then at that point, once we're happy with our wall angles, the overall look of the wall, we know that it's actually going to fit in that space with our limitations. We can approve that, and then we're moving on into the structural engineering of it. And then we take that design, we're going to build out the framing behind the wall, make sure that gets approved. You want a stamped engineering drawing from a structural engineer for a commercial project like this. And then we know that the framing can support all those load limits. Once that's approved, then we take our actual drawings for each individual stud or the framing setup, and we're bringing those blueprints out on the shop floor, and we're starting to cut steel, and we're moving forward on the project. Now the steel framing is going up, so let's just kind of talk through all the aspects that are happening here. We're starting to assemble it, and we're going to build these individual frames one by one. And the steel that we're using here, this is both a combination of 6 and 8 gauge steel for these frame studs that are going up. And this is heavy duty industrial steel. It's designed to hold all the load limits we have, especially in the overhung area of the bouldering cave. And at this thickness, you need some pretty burly self-tapping screws, so make sure to spec a gauge self-tapping screw that can get through the 6 and 8 gauge steel. At each attachment point, we're using 5 screws, so it's going to go in a square pattern with 1 screw in the middle, and that's at each attachment points. Now that the frames are complete, then we have to talk about anchoring it. What we're using in this setup is we spec'd out a Simpson strong tie. These are a RCKW3, and we're also using that same 5 screw pattern. And then there's a concrete screw anchor that is attaching these both into the floor and then also into the cinder block wall. Just a quick note on cinder block walls, keep in mind there's a hollow part of these blocks and then there's a solid part of the block. We're always trying to design that our concrete anchors are going right into the solid part of the block. So that is a quick run through of how we're putting these steel frames together. Off to frame this out in wood. Hey, so as you can see, we're just finishing up the steel framing. We have a few more tiebacks here on the 40-degree wall. And then this is our vertical section that the steel studs just went up, a few more anchors there, and then tying it together. So that's the first stage of framing this out, is getting the steel up. So as we're just about to finish that up, we're also going to start working here in parallel, and then we're actually going to kind of frame it out in wood. And the reason we do that is you could attach your climbing panels right onto the steel, but one of the issues is if you're putting a screw on volume or a screw on hold and you're screwing through that plywood and you hit the steel, you're just gonna, like, you can't go in. And so we actually will use the wood to strengthen our lateral bracing on here. And then it also kind of gives us that face that you can screw up, you can put a screw anywhere on this wall, and you're gonna sink in, and you're not gonna hit any steel. So for that, we're gonna just attach a 2x4. We're putting it, face against it, because again, this is just, to kind of shim it out and to frame it out for our sheets to install on. A couple of things, we just did a project and we used LSL, and so that's an engineered 2x4. You're going to get more strength out of that. For this application, we didn't need that extra strength or the cost, and so we're just using a general construction grade 2x4. It's going to be perfect for what we're using here in the shop. Depending on the project, you might need to use like a fire retardant 2x4 just for building code, but again, you're going to have to check that out. We didn't need that here as well for this. So as we install this, we're going to go ahead and use these techs. They're 2 3/4 inch lengths. These are designed for wood to metal, and so they're going to self-drill through the wood and then tap right into our metal, and that's how we install them on here. So with the 2x4s on end, we just picked up some 2 3/4, and I'll zip a couple of these in here. All right, so now that we've finished up the wood framing, we're moving on to the next step. So step 1, metal framing. Step 2, getting our wood framing on. We want, now at this point, before we start cutting any panels, we're gonna go and we're gonna get our laser out here. We're gonna run all the dimensions, and we're gonna double check everything, because we drew this up and it should match up. We anchored in the right spots and did our steel framing and everything. But generally on a structure this big, we're gonna be off a couple inches here or a ½ inch there, and that might make a difference as how our panels are coming together. We don't want those gaps. And so we're just gonna measure everything. We're gonna cross-check it with our computer model. And then at that point, we have our thumbs up and it starts to get cut on the CNC machine. And so that's what we're up to next, is just confirming everything. All right, so as you can see behind me, with our framing complete, these panels go on really quick. Once our design is in the computer, they go to the CNC machine, they get cut. As soon as they come over here, they're installing right on the wall. So let's take a look at that. When the panels come up, we are just installing them from the face with construction rated wood screws. Okay, and so we're running the perimeter and then down the center right onto that wood framing that's behind here. We do it from the front. We don't mind that aesthetic. It kind of blends in, like this is as noticeable it's going to be, but with that industrial look of the T-nut showing through and all the holes, it just kind of adds to that climbing wall look. Let's talk through the wood we're using. This is Baltic birch. It's a 3/4 inch. And if you come in here nice and close, you can see that we have, it's a 13 ply, and every ply that you have in your wood, the stronger it is. And with Baltic birch, every ply, even the interior, is all solid birch. Versus in the hardware store, if you're just going there, you're gonna get a birch, but that generally means it's a 6 ply, and the veneers, the outsides are birch, but the inside's a filler wood. And so the quality is just not there as far as like the T-nuts being able to kind of compress your plywood, and just it's not as strong. All right, on the back side, let's look. This is our industrial T-nut, has a bigger flange and installs really quick with 2 screws versus 3. Really low maintenance with our industrial, like the guided barrel, self-guided barrel. So that way you're just not stripping your T-nuts as much. And that's our quick overview. So like I said, we have panels are going up really quick. We have 4 more to finish off the top above us. And then we're moving on to the next step, which is putting in the padding. All right, so this is the part of the project where things start to get exciting, starts to move pretty quick, and we can feel the point that we're gonna be setting here in no time. So let's just kind of talk through what we're working on right now. We just put in some LED strips in the bottom, and this is our cave. And so in the they're traditionally pretty dark. And so the LED strips that we mounted are about halfway through the pad, they're just shining up. And so you're not gonna step on them or anything, but they're just kind of lighting from the bottom. We're gonna come in, we're probably gonna install some lights up here, which are gonna flood in and just kind of light it as well. So as you're designing your gym, really think about lighting. It makes a big difference as far as the overall aesthetic and then just the climbing experience. As far as the pads go here, we are using a 16-inch thick pad. This is one solid piece of foam. We've also done in the past, we're using like 2 8-inch or 2 different styles foam stacked on top of each other, but we're going with this thickness. We're 15 feet high. You know, that's a pretty big fall when you're bouldering, so we want, you know, that big thick pad to fall on. These sheets, the pad sheets, the foam comes in about 7 feet by 8 feet, so they're pretty big sections. So we're just dropping those in here, and you're gonna get some weird corners like this every once in a while. So we still need to cut this little edge. Whenever you're doing that, you wanna use spray foam or spray adhesive, and then you're just gonna adhesive that in, and that adhesive, you know, it bonds really well, and it's gonna, you know, just hold that together so you're not twisting an ankle on those weird seams. Okay, so for the ballistic nylon, really you wanna be speccing something over 1,000 denier just for the strength and durability. How we design this is essentially 3 different sections, and it's held together by Velcro. So this is 4-inch wide, super durable industrial Velcro. And what that does is allows us to sew this up and put it in different sections. So one, we can get in here and we can manipulate it a little bit and stretch it. And then is also, as far as maintenance goes, if we have to get in here and replace a foam block, say like 5 years from now or something, because it's a really high fall zone, we can just open that up, get in there, and then move that pad out of there and replace it. So it's nice for maintenance, and it's also nice for adjusting and getting any wrinkles out as it stretches out over time. Okay, so how do we install this? We use these mounting strips. We just rip some pieces of wood and we mount them in the bottom. As we're mounting that, we're wrapping the ballistic nylon around this, and it's mounting right at the bottom of the climbing wall. And what that does is allows us to give us something really tight that we can pull and then stretch this pad out and pull it really tight, get the wrinkles out and have a really nice landing surface. We're gonna do the same thing here on this front edge curb. We just pick up the pads, we go ahead and mount these in, and then we wrap the ballistic nylon around this board, pull it up. We're gonna have another Velcro strip here, and we're pulling it tight, and then we're, you know, mounting this front edge. So that's generally what we're doing here as far as the foam and the padding. It goes pretty quick, and we're off to setting some climbing holds next.